So we're ready to start the talk, GVR?
Look, he's got the
Roger that.
Can everyone hear me? Is this working? Great. We'd like to thank you all for coming out to Eclipse Day at the Googleplex. I'm Terry Parker.
My name is Robert Konigsberg.
And we work here at Google developing software that makes other Google engineers more productive. Our talk today is titled Eclipse in the Enterprise, and we're going to talk a little bit about our development environment here at Google, some of the challenges that poses to using Eclipse. Some of those are specific, unique to Google, some are not. And some of the things that the team Rob and I have worked with have done to make Eclipse more usable here at Google. So Rob,
Yes.
if I'm a new engineer here at Google, what is my life like?
It's a great question, Terry. So first of all, you have a lot of choices. You're really, if you're writing software at Google, you're not restricted to what editor you want to use. If you're an Emacs user, we're happy to have you use Emacs. If you use VI, that's great. We have a lot of users, a lot of IntelliJ users. We have a lot of Eclipse users. If you're using Eclipse, you're also fairly unrestricted by what plugins you can install. If you are a fan of AnyEdit, that's great. Find bugs, Eclemma, sounds great. But what if you want to integrate Eclipse with Google's homegrown build system? And that can sometimes have some challenges. Our responsibility then is to provide an integration between Eclipse and our build system. So what that often means is a lot of our users are not particularly interested in being Eclipse power users. They're interested in getting in, doing their work, and getting out. We wind up in that case being not just tool providers, but first-level support for tools that we don't even really write. So we wind up giving a lot of Eclipse support. We wind up, on behalf of users who aren't interested in dealing with an external bug system, we wind up reporting bugs on their behalf. We wind up dealing with, if you see me on the IRC channel, it's very often because someone else is having a problem. So we wind up doing not just tool support, not just providing tools, but tool support way beyond what we do. So before we talk about really what we do, I'll just talk a little bit about history of how we've integrated Eclipse with our build system. And as far back as I can tell, the first build script was written in about January 2004. It was a 100-line Python script, and it took a pre-built component, one of our pre-built components, parsed it apart, and created a .classpath file out of it. And you would, and then you'd have to create your .project, and all the work you did integrating with Eclipse was done outside of that on the command line. So if you had to change your build targets, you then had to go out and regenerate all sorts of things. There was no real easy support for launching, no easy support for testing. So we had these wiki pages that would tell you how to run a test, and it was like, you'd have to just append this gross class path to any launch configuration. So that's how things sort of started, and all sorts of deployment issues were managed not by a team, but by 20% contributions. And I don't know if you're familiar with the notion of 20% time here at Google, but engineers are allowed to spend 20% of their work time on things not related to their primary job responsibility. So as a matter of an example, I started working on Eclipse as a 20% project, and then about 2 months later, joined the build tools team full-time. So we don't do that anymore. We don't have a .classpath generator. That script is gone. But we now write a set of tools called Guide. We call them Guide. And it's an integration. It's a set of plugins that integrate with our build system. And creating a Guide project is fairly straightforward. It looks like a new project wizard. Fundamentally, the only interesting thing on that slide is the set of targets that you declare. These are some top-level components that you're interested in building or working on. And what happens is I have no place to put my note papers. The build system on your behalf will find the complete set of subcomponents required to actually work with your project, does a bunch of clever hackery and magic, and you wind up with a project that has a workspace populated with all the source you need, launch configuration metadata, all sorts of interesting information that you need. And you can tell when you're working in Eclipse that it's a guide project because of a big green ball. That's the only particularly interesting thing about the visual there. But that's what we do. So the end result of doing this work is that we have, excuse me, you have a workspace optimized for development at Google that not only includes plugins that might be interesting to you, but also it means coding standards for editor formatting. We have integration with JDT, CDT, and PyDev. So if you're working on a Python project, we have support for you as well. We use an Eclipse builder to directly talk to our build system. So no, you fundamentally don't have to do any work outside the workbench if you don't want to. We have a lot of custom editors. We have a lot of internal languages here at Google. We have editors to support those. You may have seen some of the languages that we've open sourced. One of them being, for instance, a protocol buffer definition specification, and that's recently been open sourced. We have an editor that supports that, for instance. And as I said, we have built-in support for launching. We started with just trying to work on top of the JUnit and Java launch configuration types, for example, and it just got too unwieldy, and now we just have our own launch configuration types, and that helps make launching for our engineers much easier. I think that's it.
So Google engineers build a lot of applications. They build AdWords, they build Google Spreadsheets, Google Analytics, and all sorts of big infrastructure that's behind web search, maps, and so on. And there's no real magic in how we get this done. We basically have a lot of developers working on a huge code base and using lots and lots of different tools. So if you're a new engineer at Google, you're just faced with a lot of information. Now, if you come to Google and try and use Eclipse off the shelf, our unique environment can pose some problems. So some of the things you might run into is refreshes that hang, because we have a lot of source that goes into building our binaries. You can see, because we hook up to an external build system, where invoking the build system takes some time even on a null build, you can get waves of unnecessary and blocking builds. If you're doing Java development, you're linking in hundreds of libraries, so you have lots of big class path issues to manage. And also for our test framework, we're fairly test-driven here at Google, so we have a very strict test framework that has some more restrictions on it than you'll find in the Eclipse JUnit. So there's some environment that needs to be set up for that. And until fairly recently, when I, myself, or someone on my team would push updates to either our guide plugins or to Eclipse overall, we could get breakages in your projects and your configuration. So there's a lot of tuning that's required all the time to bridge this gap between our Google environment and just normal Eclipse development. So deployment is tough. And it's hard in the IDEs because engineers live in their IDEs. And those engineers are typically up against deadlines or in the middle of large changes. And so if you're deploying to a large audience, you're always balancing updating features versus having stability. You're balancing having lots of useful features available to everyone versus an uploaded installation. And also the whole push versus pull issue. Are you going to force everybody to be on the same version, or can you afford to support multiple versions out there in the field? Can you take that support hit? So this is what our distribution looked like in June of 2008. Basically, we installed through a Debian-based package scheme, and we had a base installation that was essentially the classic Eclipse SDK. And then we could ship other Debian packages that were modules of features for the CDT or for guide. And the one thing that would happen is when you pushed out that peer folder that had, say, the CDT in it, we would drop another folder in the Eclipse links. We would drop a file in the Eclipse links folder that pointed to that. So that gave us a modular, manageable installation. And there were some benefits to this approach. It worked pretty well. It gave us a standard Eclipse distribution across the company, which we could build on top of and support. It was modular, and also it took some of the burden of managing the configuration off users, because at this point in time, pretty much users were responsible for making sure that they had all the plugins that were needed when they installed a new feature. And a lot of times that meant unzipping things directly into the plugins and features folder, and if you wanted to remove that feature, you had to do surgery. So this was a nice modular way of maintaining that. And then this happened. Ganymede came along and broke our distribution. Actually, I love P2, okay? I have to say I love P2, but this is what it felt like at the time. P2 was introduced fairly late in the 3.4 development cycle. And really what was going on is that P2 was coming along and filling this void of, there was no user management. The management of configurations was forced on users. P2 took that responsibility. And for us, we'd already filled that, and you had the struggle between two different installers. Installers always think they own the world. So the fundamental thing was that with P2, Eclipse took ownership of the plugins. When we would push new Debian packages, that would remove the old plugin jars with their version number and put new ones in place. And that was changing the bits out from under P2. So its metadata and caching got hopelessly corrupted. So we kind of slowed down our release cycle at that point until we came up with a better solution. And our solution was to really embrace P2 and use it. So earlier this year, we deployed a new way of releasing our Eclipse installation. And it still uses Debian packaging for two primary packages. And both of these go into a read-only partition on the user's workspace. We push a P2 agent, which is a headless installer, so that we can do scriptable installation and configuration management. And we also push something that I call a reference profile. Similar, when you go to the Eclipse page, you can download a CDT, you can download a C++ version, a J2EE version. We craft our own minimal one of these here that's fundamentally the JDT and some PDE stuff in it. And we install that in a read-only partition in the user's disk. And the other missing piece up here is we also install a launch script. So the first time a user runs Eclipse on their workstation, what happens is that launch script senses this is the first time, and it copies that read-only reference profile over into the user's space, and asks the user, do you want to install these particular plugin, Google-specific plugins, and it'll invoke the P2 agent to do that, and then you're up and running. And from then on, the Debian packages don't touch that profile. That's over in user space, and we only use P2 to do updates and maintenance from there. So are there any questions on this slide before going further? We can come back in Q&A if anybody has questions. And so there's some nice advantages to this approach. It avoids our corruption problems. When we used to push Debian packages and it was removing pieces under a running instance of Eclipse, what we used to do is we would push a package that had guide in it. That would remove the old jar files that were the plugins, put new ones in their place, and if a user was running Eclipse, you'd killed the runtime. Eventually, it just crashed. Right? And the way that P2 works now is you install these things, and it actually updates a manifest file, and that manifest file only gets read in at startup. So we can do these remote installations, and people's installations are completely stable. So not only the added issue of P2 Debians changing things out from under P2, but just changing binary bits that you might actively be running are solved by this scheme. The other thing is it makes it much easier for users to try things. In our previous installation, it was a single monolithic install, and when we asked people to beta test something, they basically had to change their single Eclipse installation to install the beta updates, and if that didn't work out, then they had to roll back. With this scheme, we have this read-only profile that you can copy as many times as you want, so you can do a quick test, and you can go out there to the Eclipse site and grab new web tools or whatever piece you want that can be in whatever alpha state and still have a stable running version of Eclipse just by launching in a slightly different way. So this has really helped us with being able to have, we standardly have ways of launching the stable and the beta versions of our software, of our development software. So let's talk a little bit about scalability. Google projects involve a lot of code, and some of that's self-inflicted, but our engineers here do expect to be able to access all the source that goes into the binaries they're building. And so we run into some of these scalability issues. Refreshes that never return, I mentioned before. Indexing of Java, C++, and Python can all be issues. Actually, Radim and our team managed to solve the Python issue. And overall IDE responsiveness. So what do we do? Well, the engineers want the source, but they don't necessarily want to edit all the source. They mainly want it for debugging purposes. They want code completion if they're using an API, but they don't necessarily need to have that all managed by Eclipse. So what we actually do is we map a subset of the source into Eclipse. And we're able to use, for Java, we're able to use backing jars. Rob's going to talk more about backing jars in a minute. And for C++, we can set up GDB so that GDB knows where all the source is. So once you launch a binary, you can always step into the file and have GDB open up that file for you, even though it's not in your Eclipse workbench. And for the indexer, we can set it up to discover these external header files. That's fairly common. Typically, you don't actually map your runtime header files or STL into your project, but Eclipse does find, the CDT indexer does find them.
So Terry briefly talked about this notion of backing jars. When you have a Java, you have a JDT project, Java project, if you've got a large source code base, you don't necessarily want all the source in your source tree, in your resource tree, because it just winds up killing your productivity and performance. So what we will wind up doing is we will take every subcomponent that has Java source and we'll build a single jar of that component. And all of those come together to be the backing jars of the project, and that reduces the amount of source that you have to compile and manage on a regular basis. The problem with that is you have a new scalability problem. So this was the slide I showed you earlier, which gives an example of some components and subcomponents. But that's not really how projects look. They tend to look a little more like this. And they actually look probably a little more like that. So it tends to be a lot of backing jars. And what happens when that comes up? Well, we had a problem recently, which I'm going to recount to you. I'll tell you a little story. We had an engineer complaining about debugging. It turns out every time he would step through the debugger, it took 10 seconds for the UI to return. So it was a 10-second delay on every step through the debugger. And one of our engineers started to look into this, and it turned out that it was source code lookup. As you're stepping through the VM, where's your source? That was a 10-second operation every time. So I need my notes. So what ended up happening? Well, this project, sorry, I'm going to show, this is the only math slide. The project had 2,200 jar files in it. And it turns out that in one path through source lookup, or maybe the only path, it's actually an n-squared operation. It's not explicit, but if you look, it turns out to be an n-squared operation, where n is effectively the number of jar files in your project. So, and that's fine. I'm not here to criticize n-squared algorithms. There are plenty of people that can criticize n-squared algorithms. But in the center of the inner loop of this algorithm, it would create a new path. And if you don't actually write Eclipse code, a path object is the Eclipse equivalent of java.io.file. And that's actually, it's not a slow operation. It does do some pre-computing of hash code and early computing in the constructor. And it's actually fairly quick. Is it? Okay, good. You can actually do 500,000 of these every second. So it's not really that slow of an operation. But what happens if you have an n-squared algorithm where n is 2,200? That turns out to be 5 million, effectively 5 million, which if you can do 500,000 of these a second, the delay is approximately 10 seconds. So it turns out that this seemingly innocuous and not really visible n-squared operation was causing a lot of pain for us. So Kelly actually found an easy fix for this. I'm going to show some model of the code. Basically, it looks like this. This is the inner loop. Inside the inner loop, it creates a new path, and it turns out that entry, which is the source of this path, is not even different on every iteration of the inner loop. It's the same. You don't need 4.8 million of these. You only need 2,200 of them. So all I did was put it outside the loop, and now source code lookup returns in less than a second. So, and this is, it's just the scalability problem that we discovered because we have a lot of jar files in our projects. So I want to take a step back and talk about deployment, actually, and how we now dealt with this user. Because we can't wait for 351. Keep pressing next, and eventually 351 will come out, but you can't wait for that. So we now have our own internal Git repository, and we keep a copy of JDT source in-house, and we now publish an internal mutated version of 350 that has at least this optimization in it. Now, yes, of course, we've reported this as a bug, and the patch is there. So hopefully we won't have to. It's not our goal to maintain an internal Git repository. We don't want to do that of Eclipse source. But clearly this was a case where it was an easy win, and it's something that we're going to have to do. That's it. Sorry.
So we've talked a little bit about how we can configure Eclipse to deal with external files, so we don't need to manage so many files within Eclipse. But if the sources are actually there, if you only want to kind of cherry pick some of the files to bring into Eclipse, how do you do that? Well, we've tried a couple approaches that didn't work very well. One was to create a symlink forest, and it's a little bit washed out, but in these diagrams, the green nodes on top are directories and the blue nodes are files. So with the symlink forest, you basically mirror the same directory structure, but at all the leaf nodes, which are files, you create a symlink back to the original the source tree for that file. And so you can basically pare down your tree that way. And the thing is, this has some bad side effects. One of the side effects is that if you want to do like a rename on a file, well, you end up renaming the symlink link, but it does nothing to the source tree. Or if you create a new file, it ends up getting created over in the symlink forest, which is what Eclipse is pointing at, rather than in the source tree. So that didn't work so well. Another approach that didn't work that well was to kind of move up at the directory level. We used Eclipse link folders, which are kind of an Eclipse equivalent to a symlink. And so at the directory level, we point over, which means that if then I want to create a new file under one of those dark green nodes, that's fine. It actually does create it in the right place. But let's say I want to create a peer folder to one of those green nodes. Again, that's getting created over in the linked resource tree in my workspace rather than where the source code actually is living. So our solution is to implement an Eclipse file system that does filtering for us. Now, an Eclipse file system is an Eclipse construct. It's very lightweight, very thin, stateless. And it's essentially just a little abstraction in between the whole iResource tree, which is what you're mainly dealing with when you're looking at navigator views and so on, and the underlying file system. So to implement an Eclipse file system is fairly small. It's just a couple classes, not a lot of methods. And the methods tend to be of the type, does this file exist? Is it read-only? What children does it have? So that's what, when you do a project, when you do a refresh on your workspace, the iResource, that refresh is going through and asking the file system, these file system nodes, what are your children, and so on. So we created an Eclipse file system that basically delegates to Eclipse's internal local file system, and the local file system is really just a thin wrapper around Java IO file. And so there are really only three methods. Mostly we just delegate to the local file system. There are only three methods we needed to do. What are your children? What are your properties? Do you exist? Are you read-only? And make dir are the ones we need to override. So what this gives, and then what we're able to do is within Eclipse we can create a folder link to the root of our whole source tree. And then when the refresh operation comes along and it asks that root, what children do you have? We can tell it less than the full number of children. So this has worked out pretty well for us. And actually, one thing to note is that there is some work that's been going on in E4 and that's going to get backported to Eclipse 3.6 for flexible resources. This is a demand coming from the C++ community to make Eclipse project configuration much closer to what you can do in Visual Studio, which is a model a lot of people are used to. And so we want to look at that, but one thing we need to make sure of is that you can actually apply that filtering before any refreshing happens. Because the idea is you actually apply the filter to the resource, but if you create the resource and it immediately tries to refresh stuff underneath it before you apply the filter, that's not going to help us. So we'll look at migrating to that, but for now, this is what we have in place. talk a little bit about configuration. Eclipse is super configurable, and that's great when you're a single user. It can be somewhat problematic when you're supporting a corporate installation. And a good example is if Rob edits a file and checks it into source control, and I check it out, and my white space and other configuration settings are completely different, I'm going to completely reformat his file when I check it back in. Nobody wants that. That's just a lot of noise and chatter. So things like editor settings and white space and debug settings are all things that you want to share. In the past, what we did at Google was someone went, set up their workspace exactly how the consensus was, did a file export preferences, check that file somewhere in there, and then it was a manual operation for everyone who was setting up a new workspace to import that. Well, eventually someone, it wasn't me, found out that there is a Eclipse framework for doing this. You can go into your config.ini file and set this Eclipse plugin customization property to be a path, and that path essentially points at an exported preference file. It's a little bit reformatted. And then just by default, all the new workspaces you create have all those editor settings. You can set up things like preferred web browsers, proxy settings. You can set up when automatic updates should occur. There's a whole range of things you can do.
So this is nice. I mean, it's helpful, but sometimes you want a little more flexibility than that. Maybe you have a localized team and you have some settings you want to share among your teammates. Or you need configuration outside of system preferences. You want certain behavior in all your projects or in all your launch configurations. Or you have painstakingly fixed your workspace to look just how you liked it, and now you find out that you have to go to another workspace. So, who's had that problem before? So I know that we're not alone in dealing with this kind of a problem. And in fact, I don't know if you saw this blog post in June on the Planet Eclipse blog, Wanted Dead or Alive, Eclipse Configuration Synchronizer, right? I mean, this guy is so desperate, he's going to take a dead Eclipse Configuration Synchronizer if he has to. So he's pretty, desperate about this. We have something that we call the Google Configuration Auditor. An auditor is an Eclipse plugin. It runs at startup, and it runs at regular intervals. And it basically looks at your workspace and makes sure it's in sync with its expectations. An audit, fundamentally, is a pair of operations, an evaluator, which looks at your environment and determines if it's in sync with the audit's expectations, and a repair action, which then mutates your environment appropriately. Notice this has nothing to do with system preferences. I don't see is preference equal to X? So audits are fairly general operation. So what happens is the auditor will find all the audits that are appropriate for your workspace, for your environment. And if all your audits pass, it does nothing. If it fails, it'll present you with a pop-up. I want to thank the Mylan community for this pop-up framework code. Thank you very much. But it provides a pop-up that says, please take a look at this, and if you do want to repair your failed audits, then you are presented with this dialog, which allows you to select individually those audits you want to apply to your workspace. So you don't actually have to accept them. This is a very flexible setup. Users just may not want them for a variety of reasons. Now, if you're looking at this and you're thinking, boy, this looks similar to things I've seen for operating systems like Windows Update, or Mac has its software update, and it allows you to choose those items that you're going to upgrade to your installation. And that was intentional. We like that sort of model of being able to present you with opportunities to make your workspace look how you like. Now, audits, just to talk about them briefly, audits can look like they can look like a glorified version of an EPF preference file with just some metadata attached to it. You can write Java classes, you can write Groovy scripts, and we also have an extension point mechanism. So we found that you need extension point mechanisms because you can't really do anything with JDT if you can't get to JDT. But this fundamentally lets you analyze and repair any part of your workspace as you like. Yeah.
we're almost done, so we'll take questions in a couple minutes. So let's talk briefly about external build systems. As we mentioned previously, we have our custom build system here at Google. And this is actually a fairly well-known problem within the Eclipse C++ community. The things you run into when you try and integrate a truly external build system that runs out of process is that from a user vantage point, the triggers are happening far too frequently. The assumption is that null builds and incremental builds are really, really fast. And one of the things that Eclipse does is it'll lock your whole workspace, which if you've got a build that's going to take some time out there means that you can't edit and save unrelated files. The whole workspace is locked, no modifications allowed. And also there's not a lot of information available from inside the builder. You don't know whether that was generated by a file save operation, whether the user actually went to a menu command and said build, so you should really honor that. Or one case that I saw is when the CDT indexer is running, it's going to regenerate markers to say for syntax errors and such. So when it gets to a file, it clears those out. Well, that clear, if you have auto update on, if you have auto building on, will actually issue a build on that. So builds can get generated all kinds of different ways. So how have we dealt with this here at Google? Well, I wouldn't say we've really solved this problem. But one thing we do is fairly standard. We have our own custom Eclipse builder that wraps our build system. And in it, we try to avoid duplicated work. We got a lot of complaints. It's like, why do we have to have the Eclipse Java compiler compiling at the same time when our external build system is compiling? So we try and avoid that and sense when builds are truly needed. And but even with all of that, we end up providing an alternate execute build command for our build system and giving the users the opportunity to totally opt out of having that be a part of automatic building, so that automatic buildings are just ignored.
I will summarize. In summary, we're pretty happy with Eclipse. It's a good choice for integrating with our build system. We regularly hit scalability problems. We hit performance issues. We're able to work our way through them, and it's mostly because Eclipse is such an open and configurable system that we can do that. If you're interested in other parts of how Google uses Eclipse, we have some talks later on in the day. Thank you very much. We'll take your questions. Anybody have questions? There's Ella. The question is whether the auditor is something that individual users can contribute their own audits to, and the answer is yes. Audits for things such as preference files and extension points are all available for users to add on their own. You can create a local directory of modified preference files, and the auditor will pick those up as you register them. Similarly, you can create a directory for your team, and as long as your team all looks to the same place for audits, you'll now have something common to manage.
Yeah, so I frequently do that. I like to have line numbers turned on, and that's not the default in any new workspace. So oftentimes you'll find something, you'll have several workspaces, and if you have all the knowledge and can configure everything initially, you can just export those preferences and import them into new workspaces. But let's say you just learn about some new setting that you like. Well, you can quickly grab it, turn it into an audit, and then as you move between the different workspaces, it'll say, hey, I have an update for you, and you can apply it across all of those.
I would love to contribute that back to Eclipse. Would you like to help me? The answer to that question is it's a matter of time and expending effort. So we'd love to do that. Scott.
Not really server-based. What do you mean by server-based management of P2 profiles? No, we haven't done a lot of that. You know, in the past, with basically the Debian technology for packaging is primarily it can be a pull or a push model. You need to know how to go out and get it. But in the past, we've primarily done a push model, and now we do primarily a pull model. And what we do is we mirror a lot of commonly desired things internally so that we're, especially Google is worldwide. Some of our offices have, more network bandwidth than others. So we actually mirror things internally for standard big components of Eclipse and let people pull. But because we have this headless installer, people can very easily just come up with a command line or a script that installs the pieces that they want and share that with people. So that's typically what we see happening is people pull the pieces they need to do their work. Yes.
Any other questions? Yes, please. Mhm. There were two questions. The first one was, how long did it take the engineer to find the source lookup debugging problem? And he could probably answer that question right now. How long did it take you, Kelly? Since we're recording this, I'm just going to repeat the answer, which was it was about a half day of profiling and a half day of work after the fact. And your other question was about how we compare IntelliJ and Eclipse support. We try very hard to share as much code as possible between. There are some plugins for the IntelliJ community. They have, in some cases, the plugins that they have a little more functionality than what we have, and so forth. Only recently now we've tried really sharing a lot of the fundamental code that, for instance, integrates with the build system. And that certainly, of course, makes our lives super easy in terms of maintenance and updates between the two platforms. But for the most part, there's really very little that we can do together. I'm not even going to try to look at how, for instance, you might put together an abstraction layer for resources, let alone Java. And then even more so. But the nice thing, I don't know if I have anything else to say. I don't know much more about how IntelliJ is really used at Google. I know that we just share some code, and it's the answer. Anything else? Okay. Thank you very much. Enjoy your day.